So this is a long answer question that has all trigonometry, sine law, and cosine law. So we're going to go ahead and have a look at this. There may be other available videos in which the idea is that we want to solve for this question mark. And often how these work is that we work outside inward because the information we get in one triangle is going to feed information to the following triangle, for the outer triangles to the inner triangles. Okay, so if we were to take a quick overview of what we have, notice how here we have an obtuse triangle, which could be something to note. Here we have two angles, so we know that this third angle can be filled in because 180 minus 68 minus 65 would be 47 degrees. We know that this is a 90-degree triangle, so that right away we know we can use trigonometry, where this would be our hypotenuse. Given the angle that we have, that side would be the opposite, and this would be the adjacent. Okay, and then we have, that's all we can really see, but then they give us some information over here. So we're going to go fill that in. FE would be 20. FA or AF would be 24. Okay, so that yields more information over there. And then ACO, that helps us with our hypotenuse, would be 39. So I would either start over here or over here. For the sake of the order of learning, let's go to trigonometry. So if I want to do the first one, we know I'm using trig, so SOHCAHTOA. And we can see that the useful information would be to find the adjacent, okay? So I want to find AB. Now, AB is the adjacent, so I know I can't use sine. And I have the hypotenuse, so I want to look for the adjacent. I have the hypotenuse, so I'm using cosine. Okay, so for AB, we know that the cosine of 20 equals my adjacent, which is what we're looking for, so that's AB, over the hypotenuse, that's 39. Okay, I want to solve for AB, so this is division, so we multiply. So we know that 39 times cosine of 20 is AB, and so that side will be 36.648. I like to leave 3 decimals, and that's approximately the length of AB. Okay, so now what I'm going to do, I'm going to grab another color, and I'm going to write that in. So now I know that this is 36.648. Okay, so now we're making progress. Now I can go ahead and use triangle number 2, or I can use triangle number 2 here. But let's, in the process of, I've got this new information, I'm excited to use it, and I know that this line is going to be helpful for finding the question mark. So actually, something that is useful you can do is highlight all the shared sides, because in general, that's what we're looking for. So we wanted to find that one. We're going to want to find that one and take a guess. We're going to want to find that one, and that'll be triangle number 3. We'll get there. So let's go back to triangle 2. Okay, it's not a 90-degree triangle, but I do have a buddy, an opposite side with its angle. So lo and behold, we're going to use sine law, where we want to find AD. All right, so let's call that triangle 2. We're using sine law. And the unknown is a side, so I'm going to put the side on the top. So A over sine, oops, that should be a lowercase. So we know that the lowercase a over sine of A is B over sine of B. Okay, so let's go ahead and fill in this information. So we know that 36.648 over sine of 68 is our unknown, so that's side AD over the sine of 65. So we're going to multiply that up there. So it's going to look a little messy, but I'm going to write it out anyway. Sine of 65 times 36.648, and you can actually write the sign after as you wish, divided by sine of 68. And that will be AB. So this is the kind of calculation similar to cosine law that is delicate. So I would definitely plug that into your calculator more than once to make sure that you get the right thing. So you'll get approximately 35.8229 degrees. and that's approximately the side for AB. So we're going to go ahead and write that in because that will help me visualize where I'm at and what information I have. Okay, so now's the fun part, the moment I've been waiting for, covering the topic of cosine. Well, again, here we have a non-90-degree triangle, but unlike in sine law, we don't have opposite side and angle, but we do have a side, an embedded angle, and another side. So that means we can use the cosine law to find side AE. So step 3, we want to find AE. Okay, so remember our cosine law is a squared equals b squared plus c squared minus 2bc cosine of A, depending on your letters. So let's go ahead and make this A and A. And then I'm just going to change this to make it more fun. That'll be B, and then that'll be C. All right? So we go ahead and plug all that information in. So our A squared is what we're looking for. Well, our A, to be more clear. So we get 20 squared plus 24 squared. Now, if you kept the letters the same, it's okay. You can. I'm just simplifying it for the sake of the formula. And it's totally optional. And cosine of 75. I'm really good at not leaving enough space for things. That'll be a 75. And then look at that. We just get to plug this in the calculator. Again, I would do that in steps. So I'm going to leave some space here. So I'll get 400. And the reason I want to do steps is you want to show your work and also minimize errors. So let's say I show the work properly, then I make a calculation error, you'll lose less marks than if you don't show the work at all. Okay, so this shows that you know what you're doing. So a squared, which is also f squared. If we stick to f, that would be a little f. But I'm not so concerned about that. 727.534. And then because we're squaring, we want to take the square root. And then that will give us an approximation of 26.9728. And that is the side that we get over here. So 26.9728. All right. So now the moment we've been waiting for, we have a non-right triangle. We have opposite sides to angles. So guess what? Triangle number 4, we get to use sine law once again. And notice how in this sine law, we were looking for a side. So I put the sides on the top because it just helps with an easy cross multiplication. And well, just bringing the bottom to the up. So I'm going to do the same thing the other way around. Whether you do it this way or not is up to you. You can keep the sides on the top and the angles on the bottom, but I'm going to go the other way around. So let's flip it. Let's say sine of A over A is sine of B over B with the spirit of I put the unknown on the top. Okay, so we get one buddy. That's the 105 over its opposite side. And then the sign of what we're looking for, so the angle is question mark, or D. Well, no, it's not D because it's angle EDA, all right, as shown here, because you're connecting the dots, EDA, and knowing that D is where the angle lies. So it's like, that is a leg, that is the angle, that is a leg. It could also be ADE, okay? And then the opposite side of the unknown angle. And in order to simplify, this goes up there. So I'm going to bring this down. Well, this time I'll put the number before the sign, if that's how you prefer to see it. And that's sign of question mark. And then I calculate this. Normally I'd calculate this and then do the inverse right away. But I'll put the inverse with an abbreviated version of what would be on my calculator. Okay, so this is all of that. Take the inverse of sine, which should be a negative 1, the question mark, and our final answer would be 46.66 is approximately the question mark. But they went to the nearest tenth, so that would be 1 decimal place. 6 is 5 or more, so they would round up. So then our final answer would be 46.7 degrees as our question mark. And our final answer on a triangle question where we work one triangle at a time, where one triangle yields information to get the other. Let's say you accidentally found this side. Well, then you can quickly use Pythagorean theorem to solve for this side. If you accidentally solve the other angle, for example, at one point, well, then you can use 180 minus your two angles. So there's no one way, but there are faster, more efficient ways to do these questions. And there you go, a little bit of cosine, sine law, and trigonometry all in one long answer question.